Hello my dear students, I hope you're all doing well. My name is Benatang Paton and welcome to the channel Classroom where we learn together. So this is the second video. We have just started electricity chapter number 11. If I'm not mistaken, it must be chapter number 11. So this is the second video. The first video has already been uploaded and today we are going to discuss on the topic electric current. So as usual, okay, what I want you to do is grab a notebook, grab a pen or a pencil, and then take down the notes because it is very important. Okay, you should have notes, and besides the notes that you get from your class teacher, okay, from your subject teacher, this should also help you. So I strongly recommend that you take down notes because notes are going to be very helpful for you. Okay, so let us go into the topic. So the topic of our discussion today is electric current. So we are going to discuss about electric current. Now, this is a simple topic, so I'm sure you will understand easily. But at the same time, it is also a little complex. Okay, there are some parts of it, some bits and parts of this topic that which are confusing. So I'll emphasize a lot more on that. Okay, and if you can understand the concept there, then I tell you, okay, the confidence that understanding this topic will give you. Okay, it's on a different level. Okay, if you understand the concept of electric current, you have already mastered the chapter. Okay, so everything is here only. Okay, this chapter electricity is very important. It's a very big topic. Okay, you are just going to learn a little bit in class 10, then more again you will learn in class 11 and 12. Okay, so whatever is being mentioned in the syllabus and whatever needs to be taught to you, I'll be doing my very best to make sure that I teach you the right thing, okay, in the right manner and in the right way, so that it will be beneficial for you, so that you watching this video is worth your time and you have that, and also that you learn something out of me, okay, out of this channel. Okay, that is the sole purpose for the existence of this channel. Okay, so before we go deep into the topic, let us do some quick revision. So there are three types of substances. Okay, we have conductors, insulators and semiconductors. So let us first learn about these things again as a quick revision before we dive into the topic, because the knowledge of these three is going to be helpful to study to discuss this lesson. Okay, so what are conductors? Let us first define what conductors are. So conductors, so like I said, my dear students, please take down the notes. Okay, so conductors are those substances, okay, which allow current to pass through. So allow current to pass through. So conductors are those substances which allow current to pass through. Point number one. Okay, next point, they have free mobile electrons. Mobile means free moving, which can move. Free mobile electrons in their outermost shell. So very important. So see, conductors. Okay, so when I say conductor, okay, examples of conductor, if I ask you to give me an example of conductor, example of conductor will be copper, aluminium, okay, etc. So these are all examples of conductors. Okay, copper, aluminium, they allow current to pass through them. Okay, next point, they have free electrons in the outermost shell. Now how come they have got free mobile electrons in the outermost shell? If I ask you this question, how come they have free mobile electrons in the outermost shell, what will you answer? Anyone? What will be the answer? The answer is, see, because they are metals. Okay, the answer is because they are metals. They are metals. Now, how come? Okay, why is the answer because they are metals? See, they are metals, and remember in the previous lesson which we have learned in metals and non-metals, metals have a property, have a tendency to lose electrons. Being metals, okay, being metals, they lose electrons. They lose electrons. So they have this ability to lose electrons. Okay, so metals, if we take, say example, if we take this element X, okay, now in the innermost shell there will be 2 electrons, okay, then in the next shell there will be 8 electrons, and finally let's say we have 1 electron here, okay. So this electron, okay, this electron in the outermost shell, in the third shell, this metal will lose its electron, okay, this metal will lose its electron. So this is the free mobile electron, okay, this is the free mobile electron, means to say this is the electron which can move. This is the free moving electron, okay, this is the free moving electron. Not only that, this electron, okay, if a non-metal comes here to bond with this metal, this electron will be given to the non-metal. So this metal will lose this electron and gain a positive charge, and then this electron will be given to the, when this electron leaves this metal, this electron will go to the non-metal, and then a bond will be formed, okay, and this metal will get one, well, the number of positive charge in this element will increase, so this becomes a positive ion, and the one who receives the negative electron becomes a negative ion. So now we have already learned this in the previous videos, okay, in metals and non-metals. If you have not watched this, okay, I will recommend that you go and watch that video, because there I have explained thoroughly, okay, what a metal does and what a non-metal does. So basically here also, okay, even in this lesson, okay, the electrons are very important. To understand current flow, electron is very important. So here lies the concept. So your concept building starts from here, okay, concept. This is the first concept, okay. This is the first concept you have to understand, that these free electrons, they play a major role in conduction of current. Remember this. So free electrons play a major role. I'll just write major role, underline this, major role in conduction of current or charge, okay, current or charge, they are same. So the free electrons, they will play a major role in conduction of current, all right, remember. So this free electron becomes very, very important. So metals have this electron, okay, this free electron, and this free electron is free, okay, it's free to move, so it will move, okay, and when this moves, okay, the movement of this free electron, the movement of electron is what actually constitutes, okay, current, okay. We'll discuss more about this in the upcoming lectures. So for now, just remember that metals carry this free electron, and it is because of the presence of this free electron that metals, okay, metals like copper, aluminum, okay, they become conductors. So metals carry free electrons, and the presence of free electron makes them a conductor. I hope you are clear, all right. So moving on, next we have insulators. So next point is insulators. So who are insulators? Insulators are the exact opposite of conductors. So if, see, so conductors allow current to pass through. Insulators, okay, insulators will write the opposite of what conductors do. Insulators do not allow current to pass. True. Okay. Next point, they do not have free mobile electrons. Now why, okay, why don't they allow current to pass through them? The answer is here. The second point is because they do not carry, or they do not have free mobile electrons, okay. Unlike metals, okay, unlike conductors, these insulators, they don't have this, okay, they don't have this free electron, okay. So that makes them, okay, that makes them a insulator, okay. Because of the absence of free mobile electron, they cannot conduct current, so current cannot pass through them, so that makes them a insulator. Example of insulators are, one of the best example is glass and rubber, okay, paper, okay, all these are good examples of insulators, all right. Then moving on, we have semiconductors. So who is a semiconductor? Okay, semiconductors, they allow only a small amount of current to pass through them. So allows a small amount of current to pass. So semiconductors are those substances which allows a small amount of current to pass through. Okay, a small amount of current to pass through. All right, we can also say they allow partial movement of current. Okay, we can also say they allow partial, because only a part, okay, partial movement or flow of current. In exam, whichever word comes to your mind, you write, both are correct. So they allow only a partial movement or partial flow of current. Okay, now here, do not think, if this is a semiconductor, don't think that, okay, don't think that, let's say this part is insulator and this part is conductor. Don't think like that, don't have this wrong idea. Okay, if this is a semiconductor, then okay, from here to here, okay, the material itself, okay, from the head to the tip, from the toe to the tip, okay, the whole material, okay, is insulator. That means it has got a mixture of both conductor and insulator. Not like 50% from here to this side are all conductors and from here to here are insulator. Like this though, this is not how semiconductors are made. Semiconductors are not made like that, okay? They are a mixture. So the whole material is a mixture of both conductors as well as insulators. They have got properties, okay? They have got certain properties which make them conductor. They have got certain properties which make them insulator. So they have a mix. They have a mix property. They have a mixture of properties, okay? So examples of semiconductors are, example, very important. Actually, semiconductor is very important, okay? We need to study semiconductors. So importance should be given to semiconductors. Okay, you have been learning about conductors, insulators from your class 5, 6, 7. Okay, so example, silicon, comma, germanium, okay, etc. Okay, so at least remember the names of these two semiconductors. All right, so this was just the introduction. Now we will move ahead with the main topic, electric current. So let me just erase this and let's move ahead. I hope you are taking down notes, my dear students. Okay, these notes are going to be beneficial for you. Believe me, okay, these notes are going to be very helpful for you. So when you study, these notes are going to help you study properly and let you understand in the exam hall. So kindly take down the notes. Now we'll go to the main topic, which is electric current. So first, let's define what is electric current. So define what is electric current. So let's try first, what is electric current? So what is electric current? Question mark. Answer. So what is electric current? Anybody? Anyone who can define what is electric current? What is electric current? So electric current is the rate of flow of electric charge. Electric current is the rate of flow of electric charge. Okay, electric current is the rate of flow of electric charge. So what does this mean? Okay, what does this mean? So in order to understand this, let us take an example. Okay, and after the example, you will understand clearly, okay, what the definition means. So to understand this better, let's take an example. Let's take two wires of the same thickness. Too long also not good. Let's make it a little shorter. Let's make it bigger and shorter. So let's take two wires. Wire number A, okay, and let's take another wire. Remember, I have to make the thickness same. So let's say the thickness is same. Okay, so it should be of both the same thickness, same length, same thickness. Okay, now say, let us observe this wire number A, okay, and wire number B. let this be wire number A, let this be wire number B. Let us observe this wire number A for 1 second. So let us observe this wire for 1 second. Let us also observe this wire for 1 second. Okay, so in 1 second, what we observe is that 3 coulombs of charge are passing through in wire number A. Alright, in 1 second, remember we are observing this wire for 1 second. 1 second here, 1 second here. We are observing for 1 second only. 1 second, 1 second. So the timing is fixed. We are observing for only 1 second. Then here in that 1 second, 1, 2, 3, 4, 5, 6. 6 coulomb of charge. Okay, 6 coulomb of charge is passing through the second wire, wire number B, in 1 second. Now my question is, okay, in which wire more current is flowing? More current is flowing. This is the question I'm asking you. So tell me, my dear students, in which wire, okay, would you say more current is flowing? Wire number A or wire number B? Tell me, which wire would you pick? Is it wire number A or wire number B? Yes, the answer is wire number B. So more current is flowing wire number B. Now, how? Tell me, why did you say wire number B? You could have said wire number A, but you picked wire number B. So you tell me, okay, what made you pick wire number B? Why did you say that more current is flowing wire number B? Is it because more charge is flowing per second? Is it because more charge is flowing through the wire in a given time, in a fixed time? Yes, that is exactly the answer. Okay, so it's wire B. More current is flowing wire B because in a given time, more charges are passing through. More charges are flowing in a given time. In a fixed time, okay, more charge is passing through in this wire. That's why wire number B has got more current. So the answer is wire B. Wire B. Okay, but the reasons why reasons why B, why B, reasons why B. Let's just search like that. Why are we picking B? Why are we picking B? Let's understand. Okay, let's try to answer this. Reasons why we are picking B. Why are we saying that more current is passing through B? The reasons are, number one, because more charge per second. Isn't it? Here in a given time, okay, in a given time, 6 coulombs of charge are passing through. Whereas here in the wire A, in the same time, only 3 coulombs of charge are passing through. So more charge is passing through here. Okay, that means more current is passing through. Is it not? It's common sense only. In a fixed time, if more charge is passing through, we will say that that wire has more current flow. Yes or no? Okay. Then point number two. Point number two is speed. Okay, speed. Now here, okay, here the speed, okay, here the speed of the electrons, okay, the speed of the electrons is fast here, whereas the speed of the electron here is slow. Now how is it so? Now let me explain to you. Remember what I told you earlier, that charge is carried by free electrons. Charge is carried by free electrons. Remember this, okay? Charge is carried by free electrons. So charge is carried by free electrons, okay? Or the movement of electrons is what we call charge. So if this is a charge, if this is an electron, if this is a negative electron, okay, the movement of this negative electron is called charge. All right, it's called charge. So charge is carried by free electrons. So when this electron move, charge is also moving along with it. Actually, this is the charge, okay? This electron itself is the charge, but we can also say that charge is carried by free electrons. So the free electron, which is the negative electron, okay, which is the negative electron, when it moves, it is the charge, okay? So what you see, you are seeing a negative electron move, okay? What can you say this to be? You can say this to be charge also. So charge is carried by negative electron. When I say charge is carried by negative electron, I mean to say this itself, okay? This is a negative electron and this negative electron itself is the charge, okay? Don't worry, Okay, this is why I said now this lesson is going to be interesting. Okay, the interesting part has started now. Okay, so this very part of the video is the part where it will brainstorm you. Okay, some of you may easily understand this, some of you may have a little difficulty, but do not worry. Okay, there are many lessons, there are many videos coming on this topic, so don't worry. But from today itself, from this video itself, okay, remember this, my dear students, that remember that charge, okay, the thing which we call charge, okay, charge is nothing but the movement of the negative electron. Remember, the negative electron moves. So this is the negative electron. Inside the atom we have proton, neutron, electron. Forget about the proton, forget about the neutron. Focus on the electron. So this is the electron. Remember, metals have free mobile electron. So let's say this is the free mobile electron. Being free and mobile, it can move. If it was not able to move, then how will this metal donate to the non-metal? But since it can be moved, so this free mobile electron can move. And when this free mobile electron move, what happens? Charge. It is called charge. So the movement of this free mobile electron is what we call charge. So we can also say that charge is carried by electrons. Charge is carried by free electrons. Okay, remember. So I hope it is clear. Charge is carried by free electrons. When I say charge is carried by free electron, I mean that when this free electron moves, charge is he himself, the electron itself is the charge. That's why we say charge is carried by free electrons. I hope I have made myself clear. Alright, okay, thank you. So remember, charge is carried by free electrons. So speed, now you see here 6 coulombs of charge, okay, they pass through. Okay, how is that there so many of them were able to pass through? Because the speed of the free electron here is the electrons is traveling at a higher speed here. Okay, whereas here only 3 are able to pass through. That means the electron speed here is slow or fast? Slow. Here the electron speed is fast. That's why in that given, once again, 6 of them were able to pass through. 6 coulomb of charge passing means 6 electrons are passing. Yes or no? Alright. So that is point number 2. Point number 3 is flow. Okay. Flow is more here. Okay. Reasons why we are saying wire B has more current. Okay. Reasons why we are saying wire B has more current is because of flow also. Here the flow is more. Here the flow is less. Now why am I saying that the flow is more here? How should I explain to you what makes me say that the flow is more here? I said that the flow is more here because of the speed. I'll give you a scenario. So 2 scenarios I'll give you. One time, okay, I'm walking slowly. Okay, when I'm walking slowly, what is my speed? Fast or slow? Slow. Next time, I'm running. So when I run, what is my speed? Fast or slow? Fast. Okay, now you tell me, in which case my flow is more? When I'm walking or when I'm running? Where is my flow more? Definitely when I'm running, isn't it? My flow is more when I'm running. So in the same way, okay, that means a fast moving object has got more flow, high flow. A slow moving object has got slow flow, low flow. Yes or no? Accepted? Good. So that is it. So this has got more flow. So because of these reasons, okay, and here this has got low flow because here the speed is also less. Here the speed is more, so it has got more flow. So because of all these reasons, we say that wire B has more current, more charge is flowing in wire B. Are we clear? Are we clear, my dear students? Yes? Sure? Alright, thank you. So, okay, remember, my dear students, okay, this is the reason why we say wire B has more current flow. This is the reason why we say more current is flowing in wire B. Alright, so now let's come back to the definition. So what is electric current? Electric current is the rate of flow of electric charge. So the rate of flow of electric charge is more here. The rate of flow of electric charge is less here. So this wire has got more current flow. This wire carries more electric charge. Okay, this wire carries more electric current. This wire carries more electric charge. Electric charge, electric current, they are same. Okay, remember that. So now, so we can say like this, that current current is equal to, okay, amount of charge flowing in a given wire divided by time taken. All right, from the definition itself we can say that current is simply the amount of charge passing through a wire divided by time taken. So we can write amount of charge divided by time. Current is represented by symbol I, and amount of charge, what is the symbol for amount of charge? Remember the previous video, it's denoted by capital Q, and T is denoted by T. Okay, so this is the formula, okay, for current. I is equal to Q by T. All right, and the unit of current is, what is the unit of current? The unit of current is ampere. It's ampere. All right, the unit of current is ampere. Now there are other smaller units of, okay, current. For example, 1 microampere is equal to 10 to the power minus 3 ampere. Very important for MCQ. And 1 milliampere, this is milliampere, sorry, this is microampere, okay, it's equal to 10 to the power minus 6 ampere. These values are important for MCQ. So MCQ, for your MCQ, this is very, very important. Okay, remember, this is called 1 milliampere is equal to 10 to the power minus 3 ampere, and this is micro. Okay, this is 1 microampere, which is 10 to the power minus 6 ampere. All right, so I hope you have taken this down. Okay, I'll erase this and we'll discuss further. We're almost coming to the end of the discussion for this topic. Now all I have to do is tell you what is 1 ampere. So let us define what is 1 ampere. So moving on, okay, moving ahead, now we have to define 1 ampere. Okay, so ampere is a unit for current, is not? Ampere is a unit for current. So define 1 ampere. So how do you define 1 ampere? So answer, define 1 ampere. So current is said to be 1 ampere when 1 coulomb of charge passes through the wire in 1 second. This is it. Current is said to be 1 ampere. Define 1 ampere, or when is current said to be 1 ampere? Current is said to be 1 ampere when 1 coulomb of charge passes through the wire in 1 second. So mathematically, how will we express this? We can express this like that. So 1 ampere, okay, current is said to be 1 ampere when 1 coulomb of charge passes through the wire in 1 second. This is mathematically how you write. Define 1 ampere. 1 ampere means when 1 coulomb of charge passes through a wire in 1 second. Clear? Easy, na? Okay. So this is the definition of 1 ampere. Then next point, remember, okay, instrument to measure. We have an instrument to measure current. Instrument to measure current is equal to, it's called ammeter. Very important. Then certain things that you need to know about ammeter. Ammeter is always connected in series. So ammeter is always, remember, always, okay, it's always connected in series. I will tell you, okay, we'll be talking about series and parallel connection in the upcoming videos. Okay, for today just remember it's connected in series. Okay, then next point, resistance of ammeter is very low. Means to say that an ammeter has got very low resistance. Now why does an ammeter have very low resistance? To answer this question, you just tell me for which purpose is ammeter used. The ammeter is used to measure current. Resistance, on the other hand, is a property of a substance to oppose the flow of current. So now if the ammeter has got high resistance, then it will oppose current flow, isn't it? So then how will it help you to measure current, isn't it? It makes sense, no? If the machine to measure current opposes the flow of current, then how will it give you the current reading? Understood? So the machine to measure current, which is ammeter, should have low resistance so that it can give you the actual value of the current passing through the wire. Okay, so the ammeter always, the resistance of ammeter is always made low. That means ammeter should have almost zero resistance. Understood? Okay, and then how is it drawn? In a wire it will be connected like this. Okay, this is the ammeter, plus minus. This is how it will be drawn. This is how it will be connected. Okay, the ammeter will be connected in the wire. Okay, so this is it. Okay, so this short topic about electric current has concluded. Like I said, this video is very important. Okay, so concepts have been discussed here. So every time you have your doubt, revisit this video again and again. I'm telling you, my dear students, this short video is very important. Okay, big concepts, especially the part about the electrons carrying the free mobile electrons. Okay, the movement of the free mobile electrons being the charge itself. That part you have to understand. So if you have still not understood, go back, rewind the video and watch again. I assure you, if you don't understand in one time, try 2 times. If you don't understand 2 times, try 3 times, 4 times, like that. Keep trying, keep watching. Again, finally you'll understand. Okay, that's how we understand things better. At one time you may not, but if you are consistent and persistent, you will understand. That's the power of your brain. Okay, all you need is just an interest, a thirst, an interest to learn. Okay, then got it, you will understand. So the video, before I end the video, has a question that I'll ask you. So please comment the answer, in the comment box. So the question is, how many electrons are present in one packet of charge? So to answer this question, you may have to visit the previous video. It's been discussed here. So the answer is very easy. The answer, you kindly comment. You give the answer in the comment box. Remember, I always go through your comment, and it encourages me and it motivates me. So keep me motivated. Keep me dedicated, keep me motivated, and for this I want interaction from your side also. So you keep me motivated, and from my end I will keep you updated. I'll feed you with knowledge, and I'll help you make science easier. Leave that to me. Leave the science topic to me. Leave the science subject to me. You need not worry, I am here. So it's my duty to make it easier for you. So leave that to me, and you, on the other hand, keep participating, keep watching, and keep learning. So that is my prayer and my greatest wish upon you. So never stop learning and progress in life. So with this positive note, we will end the class from today, and I'll see you again in the next video.